back in, he won't say how long, but I met him back in 2000 when I was running the Explorer program, and he was running a university satellite called ChipSat, which he really did a fantastic job on. And as we were talking at lunch, he's been commuting a lot during his life, and commuting from the coast, you know, from the Atlantic Ocean to Goddard almost every day. It took me every week still. But anyway, then he moved on to be the chief of balloon program at Wallops, and then I saw, and then he was a senior program executive for the suborbital research, and I saw him at headquarters back in 16. That was kind of nice to see him again. And then I saw him over at Coach 600, where he was a deputy for a few years, and now he's finally back at his favorite place in the world, the director of Wallops Flight Center. So please welcome Dave Pierce.
Thank you, Tony. And I would like to introduce my deputy, Bob Jameson. So we're going to tag team this for you today. And Bob has led our launch range at Wallops. And before that, Bob came from the Air Force, now the Space Force, and managed launches out at Vandenberg and elsewhere. So between us, my forte has been the suborbital program, principally at NASA, and Bob brings all this skill from working with DoD and the launch range. So together, we cover the waterfront. And true story, I saw Jan at the Goddard Memorial Symposium back in, I guess that was March. Bob and I were talking there. And I said, can you get me to come to the Goddard Retirees? It's my favorite. I do a lot of presentations. I kiss a lot of babies, or I don't know, go to Rotary clubs, but this is the best place. So thanks for having us here. I love the stories. Bob and I love to talk to our retirees, both at Wallops and at Goddard. So thank you for having us. So we're just going to try to whip through this. If you have questions, just stop us and we can talk about it, okay? With that, here's an aerial shot of the main base. If you haven't been there in a while, we have 3 runways. It started out, we're in our 78th year at Wallops. We were enacted by Congress in June 27th, 1945, and on that day, we didn't launch 1 rocket, we launched 7 rockets. And since then, we've launched over 16,000 rockets. This is a very exciting time, as you know, for Artemis and all of what we have spent our careers and lives doing, and no more so than what's going on down at Wallops. A lot is going on, and glad to share that with you. Let me go from there. We are, of course, a remote facility at Goddard Space Flight Center, and to that point, I was just with Dennis Andrusik, our center director, and Dennis wanted me to convey his best wishes to each and every one of you. You may be aware that Dennis will be joining you very soon. Dennis is going to be retiring on the 31st of December, as is Ann Kenny. And they both now have announced their retirement. So Bob and I have really enjoyed working with both Ann and Dennis. And they've been great champions of Wallops as part of the overall Goddard mission at NASA. And we're going to miss them terribly. And of course, you know the other facilities. Bob and I manage the Columbia Scientific Balloon Facility, part of the balloon program. We do that as well from Wallops. We like to say we're a unique national asset. And what we mean by that is we're very proud to be a part of NASA and to support NASA. But we're not a NASA-only facility. We also support the nation. We are supporting the Science Mission Directorate, and within that we support heliophysics, astrophysics, earth science, and planetary science. But we also support the Space Technology Mission Directorate doing technology work. We support human exploration with these rockets that we're launching. And then we also, with our airfield, we can support the aeronautics research and mission directorate. So we really like to think that we have a broad portfolio, but then we also, Bob, support DoD.
Okay, good point. So thanks, David. We haven't rehearsed any of this, by the way, so he's catching me flat-footed, but I'll do my best. Yeah, I'm glad you mentioned that. So coming back, Wallops has a long history of supporting the DoD, going back to our beginnings as NACA, where we're really doing aeronautical research on airfoils strictly for the DoD, right? And then even when NASA first started, we were very closely connected with the DoD, and Wallops was the place that was happening. So we continue that proud tradition. What you see up here, one of our launches is the Minotaur launch, which we accomplished last year. And we've done a series of these. This is for the NRO. So we're providing, on-orbit observation for the NRO to directly support the warfighter. Rocket Lab, although commercial, this is strictly a commercial entity. DoD this is their future, commercial launch. Everything you see, they're going away from government launches. It's going to be purely commercial launches, so that all they're buying is a service. And Rocket Lab is their main provider for small launch vehicles, and all of those launches will be happening in Wallops. So the very first one, next month, December 7th. So we're really on track here, and that's on the heels of what you see on the far left there, the Antares launch, which was, again, commercial, but for NASA, which we just did yesterday. Hard to believe it was just yesterday. It was like no longer than so. But I just want to point out, and I think we might have another slide towards it, but talking about that DoD connection, just a week and a half ago, we did hypersonic missions for DoD, and that was our, we've done several of those for them. It's a series of campaigns we're doing. You can see that grow. We may be doing up to 40 flights a year of hypersonics, and that really harkens back to the time in the 50s when we initially started doing hypersonics research up to Mach 15. But we're doing that again. If you watch the news, you know that around the world, the U.S. is behind in some of this hypersonic development, where we set it aside for so long, and China and Russia and others are actually on a task where we are. So we're catching up, and a lot of that work's being done at Wallops. We just flew that mission, we did a Mach 8 flight, low-level flight. So we'll keep building that capability, and Wallops is going to be a big part of that.
Thanks, Bob. It was really amazing to see this rocket go horizontal the other day, and we were looking at the data, and it's going 9,000 feet per second. You go, okay, that's pretty cool. So, and as Bob was also mentioning, the commercial sector, we have a commercial spaceport at Wallops, the Virginia Commercial Spaceflight Authority. So between NASA, our support for DoD, as he mentioned, we're supporting Chris Scalise and NRO, and then all these commercial companies that have a brand new rocket, they need an operational test facility to come to. And so not only do we provide our suborbital mission, but we provide an operational test facility where they can come out and test a rocket for the first time and do it safely. We're about 1,800 people, about 300 NASA civil servants, and about 800 NASA contractors. But then we also have partners and tenants with the Navy, NOAA, NESDIS, Virginia Space, the spaceport, Northrop Grumman for the Antares rocket. Rocket Lab is our newest partner. They came from New Zealand. They're headquartered now in Los Angeles. And then, of course, the Coast Guard at Chincoteague. They have housing we provide for them. And the Navy sits on our property, as does NOAA. We have an annual budget from NASA of about $335 million. But we do reimbursable work for all those other agencies. And so we're bringing in about $50 million a year in reimbursable work. So it keeps us really busy. It helps us invest in infrastructure and equipment, and it keeps our people really, really sharp. So really cool about that. We serve as an economic engine on the Delmarva Peninsula, Delaware, Maryland, and Virginia. We bring in, and we have an economic impact of about $1.4 billion a year. And it touches about 6,000 jobs in the hotel industry to restaurants. What we're doing every time we launch, the hotels are absolutely full around Wallops. So this is great for our economy. But what you all know and I know is the thing that Bob and I are trying to do the most is inspire that next generation to want to go into STEM and to go into space exploration and aeronautics. So we're really proud of all that. So here's a little video of what we do. So here's our 5-year strategic goals. We want to continue to advance the suborbital program. We want our balloons to be able to fly longer. We're working on a 100-day balloon. We want to increase our ability to communicate data down to the ground from our suborbital platform. So higher data rates our science community needs. We need to be able to recover payloads in the water, so we need water recovery. We need to be able to send suborbital platforms such as balloons to other planets if needed. All the while reducing the cost and the risk of infusing that technology, right? We take technology from Goddard out of the lab, we fly it on suborbital, we get to recover that, refurbish it, refly it again, and that reduces the cost and the risk of infusing it into an explorer's mission later on. So that's how we fit as part of the Goddard Space Flight Center. We're working on small satellites. We manage over 30 small satellites for NASA, a portfolio over $242 million. And we're managing, working with universities from California to Maine to do this, where we enable them, we provide them with mission enabling information, we bring in engineers from the Greenbelt campus when they have questions, much like what I was doing when I was working for Tony in Explorers. And then, of course, Bob, why don't you tell them a little bit about launch range in the future?
Yeah, so, it's kind of towards what we talked about, everything's going commercial, right? And we're no longer putting in these huge, robust range systems to support government launches where it's end-to-end government mission assurance, but we're buying a service from the commercial industry. And part of that means that we are going to see a huge increase in launch rates as we go to this commercial route where it's a mix of commercial and government activity. And also, all of these commercial entities are going to automated launch vehicles in the sense that the flight termination on those vehicles is all automated. So you don't have a person on the ground, which means you don't need all the radars, you don't need the command systems. And so that drives us to a more sustainable future for our range, and we need to adjust. But beyond that, we also have to have all those tools to assure that a launch rate of, up to 50 a year out of someplace like Wallops, so we can sustain that, right? So we've got to have systems that are really adaptable, that we can configure from mission to mission very quickly. And so that's where our focus has been, in going into the automation and supporting real-time risk analysis of flight operations. And of course, developing those systems that are going to allow an automated flight termination system to work, right? That's a huge undertaking. It's been going on in the government for 2 decades, and we're right now on the precipice, driven by Wallops, of making that happen. I think you probably got a slide in there specifically on that, so I won't go into it too much, but it just shows you the significance of it and how important we consider it, right? That's the launch range in the future, is an automated range where somebody can roll up, set up, and launch within about 2 weeks rather than the typical 6-month time frame that we've seen in the past. So, yeah.
Thanks, Bob. And, we're part of the Goddard Engineering Directorate. Each of the organization's divisions, whether it's systems engineering, mechanical, electrical, software engineering, we have those divisions at Wallops, and we report to the Greenbelt campus. And we want to advance that engineering expertise. We want to hire the best and brightest young people that want to come to Wallops and get their hands dirty to be able to design, build, test, and fly something very quickly. And often, we keep them for about a year, and then they leave, or they'll stay for a lifetime. And we're looking to grab as many folks that want to come to Wallops and work. And then, of course, we want to update our facilities and our technology. We want to improve our processes so we can, if we're going to do this launch rate, we have to improve our processes to be able to quickly turn over the launch range and get ready for the next launch. And we're going to do that through building a stronger Wallops with a highly skilled young workforce. We signed partnership agreements with all our local universities in the area and community colleges. And we're really turning up the game on having internships at Wallops, so kids can come in, really get their hands dirty, and really fall in love with what we have done. And we're standing on your shoulders, where we are trying to teach the next generation how to build stuff and fly it, and how much fun that is, and what you learn from doing that. Of course, as you all well know, we manage the suborbital program. We still manage about sounding rockets, balloons, airborne science aircraft. That's where I met Jan years ago. And then, of course, the small satellites I was telling you about. We do that using our research airfield as well as our launch range, and Bob will tell you more about that in just a minute. Our sounding rockets office has had a great year this year. We established a launch range in the outback of Australia during the pandemic, and then went and launched 3 astrophysics sounding rockets this summer. We hadn't been to Australia in 30 years to launch it. It went all the way back to, I guess it was the supernova of 1987A, since we had been back for a campaign. So really proud of our people. We're dealing with shipping issues associated with the pandemic. We saw supply chain issues on the television. We used our C-130 airplane to load up all the cargo for the campaign and take it to the outback. And that's one of the ways that we were using our assets across the facility to support that. Here's a picture showing the parachutes that we tested for the Mars 2020 for the Perseverance rover. We tested those on a sounding rocket. That's what we do at Goddard, right? Is that we're going to lower the risk of the flight project by using suborbital. And there you see a picture of our Australian team. And this year, I think we're going to launch about 20 rockets this year, and from universities from across the country, and 5 campaigns. And we're reaching about 300 graduate students and undergraduate students participating in the program. So as you can tell, the sounding rocket program is really, really healthy.
Yeah, if you saw that picture there with all the students out at the launch site, and what a great capstone experience, right, for a graduate student or an undergraduate student to get to build that science project, come out to Wallops, and really be just a couple hundred yards from that launch. It's pretty impressive. So, we talked about the sounding rockets. Similarly, the balloon program, this is the world-class scientific balloon program, obviously. And we're doing about, well, you can see the numbers there, on the order of 20 flights a year around the world. Right now, our team's out in Antarctica, getting ready for that mission. I know they're dealing with some, believe it or not, still dealing with some COVID issues down there that might delay things. And then the future for us is building what's called a super pressure balloon, where we get dwell time of up to 90 days, Dave. Is that right? Yeah, 90 days. With rather than being limited by our traditional zero pressure balloons here in terms of how long they can stay on station, we can get there for a very extended period of time with payloads well over a ton, right? So a payload that's equivalent to a major satellite at near orbital altitudes. We can do that with a balloon at a fraction of the cost. And we can do it with the Wallops developed systems called the Wallops Arc pointing system, or Wallops Arc second pointing system. So it's a sub-arc second pointing system for telescopes. So believe it or not, suspended from a balloon at altitude, you're a very stable platform, and you can do very, very significant science in the deep space. And so, about well over 100,000 feet for these missions. These balloons at float, they get bigger as they go up. At float, they're the size of an NFL football stadium, just for scale. So this is really impressive capability that Dave was leading for quite some time. And then, do you want me to go on with the aircraft there? Okay, happy to do that. All right, so, and you know, our aircraft office just had an amazing year. We've been so busy. We fly 3 aircraft primarily, the P3, which is what you see here, taking off, and a C-130 and a King Air. And so the P3 is primarily been focused on snowfall. We had a great year last year looking at snowfall in the U.S. And so we have systems on board where we can actually look at the individual snowflakes that we're flying. We do a low fly with our P3 combined with a high flyer from I think it's Ames that flies that. But yeah, so in any case, they can correlate that data. So we're learning a lot more about micro storms within snowstorms. We see on the East Coast here, both in the U.S. and Canada, where these storms come through, and you see predictions and you see huge bands of how much snow that areas are expected to get, but then there'll be small areas within there where they get a hugely abnormal amount, but very small locally. So we're trying to understand how NASA's trying to understand how those micro storms are work and what the dynamics are, so we get a lot better understanding to help with predictions where there might be very, very high snowfall accumulations in limited areas. So that's the P3, including hands-on student flight projects. We have student projects here this summer. Following that, right? So that's the mission we're doing in the winter. That's the one we're ramping up for right now. In the summer, we had students on board looking at pollution in urban areas. They were primarily minority institution students coming from urban areas and trying to look at how both pollution and temperatures are affected from those urban areas as opposed to the other areas. So you may have seen some in the news because they were flying right over Baltimore and up and down 95. So some really great experiences for them as well. You'll see those shots here. And our C-130 has been vital, right? You talked about perseverance. It was what we were delivering cargo for that. We were delivering cargo all over the world for our suborbital program, as Dave mentioned. We delivered sounding rockets from the DoD to France. Basically high demand aircraft that we weren't sure we could keep, but that thing's hopping. And right now it's down in Yuma doing a commercial crew program drop test flight. So we're testing the commercial crew capsule for Boeing, and then how those parachutes will deploy to make sure that the astronauts are going to be able to safely return to Earth. So a little bit about our small satellite program. We're building a solar telescope or chronograph called Codex. It's going to go on the International Space Station next year. And we're doing that with the Heliophysics Division at Goddard. We also are working to integrate small satellites on the side of Esper rings, where you can integrate multiple small satellites on a ring and then fly under the primary satellite under a fairing where they often have excess capacity. This is going to be great because then Goddard can do science where we're flying distributed spacecraft to either measure something in great detail or spread out and be able to sense an entire field. So this is a great new capability that Goddard has, leveraging Wallops. I want you to talk a little bit about the range. Okay, so as Dave mentioned, my background is the range. And the range is what makes everything happen from Wallops. We provide the airspace, all the instrumentation, all the things that support all of our activities, from aircraft and to suborbital launches and orbital launches. So it's really just those enabling ground systems that make that happen, both on the airfield and then on the launch range. But you kind of got the flavor, right? We're doing this work all over the world. So here's what really makes Wallops special is we're the preeminent mobile range in the world, and nobody comes close, right? So we support all those science missions wherever they go around the world. We talked about Australia. We had a bare piece of dirt in Australia, and we were able to build up an entire launch range from the launcher systems all the way to all the ground instrumentation, surveillance, and then pull off that mission in short order. So that's just an example. We do those same missions from Alaska, Norway, Kwajalein Atoll. We've done it, and we're looking forward to doing a mission potentially in Peru in the near future. So that capability is really exceptional, and there's a lot of need for that both within NASA and externally. So we're really proud of that. And as you mentioned, I think Bermuda. If I talk to some of you, we have a Bermuda tracking site we built. We reconstituted that from the Apollo days, and that is now. Oh, there you go. So you see is it mentioned on here?
It's on
there. Yeah. So I'm getting ahead of myself. But we do have as we talk about the range, you can see some of the activity we got coming up. Do we have a slide in there where we talk about launch rates? We don't need to go to it right now. I just was curious, so I didn't want to get ahead of you.
There's Bermuda.
Yeah. Okay, or we'll be coming back to it. I mean, as we talked, I was mentioning the range, sorry to bounce around it, but, this is where we're headed, right? And right now, I talked about commercial space, and you see that's going to be the main driver here, especially small launch vehicles, which Wallops specializes in. So from where we're at now to where we see ourselves in the very near future, this is probably a conservative sand chart showing you what that's going to look like, and that kind of illustrates that point of launch range in the future, and now we're going to have to adjust. We're really excited about that, and Bermuda plays a big part in that. That tracking station allows us to, as those vehicles go over the horizon, or if we get plume from solid stages, that we can continue to safely track it all the way to orbit. And I threw off your cycle every day, so.
Oh, no, you're fine. And then here's a picture. That's what the Bermuda tracking station looks like today. And Bob refurbished it and brought it back. And so now, not only are we tracking Antares, we're going to track Artemis later this month on the 14th. Our crew is already there. But we also have a section of the tracking station that students from Bermuda can come out and look through the window and see what's going on. So again, we're really interested in inspiring that next generation to come and be a part of the NASA mission. We undertook something that was really difficult. Since the early 2000s, KSC, the Kennedy Space Center, and Goddard Space Flight Center had been working on how to do autonomous flight termination for space for a launch vehicle. So they just using GPS, you would be able to tell the track of the rocket, and if the rocket was off track at launch, it would terminate itself. And by doing that, you would lower the cost of a launch because you wouldn't need all the ground systems that you typically would need for radars, and you wouldn't have the range safety officer sitting there on the button. You would do it automatically. In 2020, as we were entering the pandemic, Bob and I worked with the Space Force to take a piece of software that had been developed for Rocket Lab, and we took it through testing, found errors in it, and then we stood up a project to correct the errors, take it through testing. We just finished the testing. It took us a while. It took us over 2 years to get this done, but that's what's going to enable the Electron launch vehicle Rocket Lab. That's what this is. And we built a launch pad at Wallops for Electron, and we're in the end stages here of getting ready to launch this in early December. Really proud of our folks and what it took to get there. And in addition to that, the Commonwealth of Virginia built the launch pad, and they also built an integration facility. So right now, at Wallops, in the integration facility, just out the gate of the NASA facility, is this Rocket Lab building, and they've got the rocket in there. They're waiting on 3 small satellites to come from the company in Virginia, and then they'll integrate that, and then we'll get ready to launch. Now, in the spring, Rocket Lab made an announcement that they were going to be building a Delta II class vehicle. They call it Neutron. And they are going to start building that. They've already started the program back in April. There's the governor. There's Dennis Andrusek. Here's the pad that they're building. Here's the launch range. Here's the gate at the island. They are in the process of building the facility right now. They'll go right into production of this composite rocket, and they're going to try to launch. They're going to build a facility like that, and then they're going to launch Neutron in 2024 or 2025. What's going to be really cool is they're going to fly back, like Elon does with SpaceX. They're going to fly back the first stage, and they're going to land it on a barge. So, we'll crawl, walk, run. But eventually, they're going to fly it back to the island. And so we're really excited about what the future is. And this is a behemoth. And there in the upper left, you kind of see an image, a cartoon of what they're going to try to do. They're going to try to build a barge, and then they're going to have rails so that they can take it back to the launch shelter. Pretty amazing what's going to happen. Bob was already talking about launch range. To get there, NASA's #1 priority is this bridge is 62 years old, and it has been derated now, so we have to replace that bridge. It's NASA's #1 institutional facility investment. is to replace this bridge. And it started out at $48 million, and I understand with inflation, cost of materials, over the pandemic, you can imagine where that cost has gone. So it's north now of $100 million, and it's in the NASA budget. So we're hoping that we're going to have that bridge, a brand new bridge that's flat. You can see it's flat by 2025. So we talked a little bit about how important our engineering team is at Wallops, and then education. We have an agreement with Junior Achievement, and we hosted 3,500 eighth graders in the spring. Eighth graders are at a time where, in that spring, they're going to make decisions on do they pursue an academic track in high school. And so we reached kids from Virginia and Maryland all at 1 day, or 2 days. And we did it with a cluster of all of our scientists and engineers from across Goddard at Wallops in the Salisbury Convention Center. So that's the kind of outreach we're doing. As I mentioned, Dennis has signed agreements with our local universities to increase internships. So we're worried about the future. And we have our interns come, and then they do poster sessions. We had a Sound and Rocket Symposium this summer with our community. We also have a Learn Forum on small satellites. So we're trying to bring the community together so that everybody can learn and to make a stronger science community. That's what we have to present. Any questions from anyone? Thank you. Yes, Mike.
I wanted to talk a little bit more about the balloon program in Antarctica. Are you recovering balloons at certain altitudes below down there?
So, Mike, we launch about 3 balloons a season down there. We've done an environmental impact assessment, and as you know, when we terminate the flight, they come down. We go out with a Basler or a Sherpa, a small airplane, and generally speaking, to get it through the door, we have to dismantle the instrument. We do not have a capability to recover the balloon carcass itself, and over the course of a year, since you've been there, you know quite well, it'll be covered in about 3 feet of snow in just 1 year. And working with the National Science Foundation, we found that it's a lower, since it's an inert material, it's not going to be an environmental hazard. They found that, the scientists found that it's a lower impact if we just leave it there and then it's embedded into the ice. So we don't recover the balloons there, but we do recover the balloons everywhere else, including if we put them down in the water. We go out with the trawler and get them. So if we did it off the shore, we would have to go get them. Thank you, Mike. Yes, sir.
I'm curious about the commercial launches. Like in the case of Rocket Lab, is there really exchange of funds, exchange of services? Is it a competitive process?
Yeah, that's a good question. So just in the sense that, everything that we do, the government does for commercial or other government agencies for that matter, and we still do recover all those funds, right? So we charge them for all direct costs. And so we enter an agreement with them, they have to pre-fund it, and then we recover all that. The competitive piece is, who gets there first, who gets used to launch facilities, I think. That's about as far as that goes. And in there, what we're really focused on going forward is having multi-use facilities, especially for these small launch vehicles, where you could have a Rocket Lab launch there 1 month, but then you might have another company like Asher come in and use that same facility in a different month. Maybe not that particular launch pad, but that's the idea, right? We're pretty limited on our space, so we have to be versatile. Does that help?
And we have signed agreements with everybody, and then we have to send money to our contractors to give us support. Yes, sir.
I know touring the facility used to be very popular at one time. With a lot of us in this room now, we get a lot of little people called grandchildren that bug me about touring this facility, and I haven't been down here in many years.
Sure.
With DOD and commercial and all the other expanding services, what's the nature of the touring now?
So we shut down our visitor center at Goddard during the pandemic, but it's back up and running, and I'll be glad to coordinate information So maybe as you all can come down on a bus, and we can give you a day at Wallops sometime if you'd like to come down. And as far as your grandchildren go, we'll help coordinate that through the visitor center. But we are back open, and they can.
Goddard Visitor Center.
Well, we have a Wallops Visitor Center too, so we'll do that, and then you can make arrangements to go down and visit. Yes, sir. Jim?
Yeah, at one time you had the Management Education Center down there. You guys still do that? Or?
No, we lost funding for it, and so Bob and I maintain the ability for people to come in and use those classrooms, but they're not managed any longer, and we're trying to keep up with the technology so folks can go in, use laptops, and use that space, but we don't have the MEC for training any longer. Good question. Yes, sir.
Yeah, is the White Sands missile range still used south of Washington?
Yes, sir. We launch probably 6 to 8 sounding rockets a year from White Sands Missile Range. The sounding rocket program goes to Poker Flats, Alaska still. We're just getting ready to launch from Norway. Told you about Australia. But between Wallops and White Sands, we probably launch 12 rockets a year between the two locations. So yes, sir. Very much still using those. And then balloons, we still go to Fort Sumner, New Mexico, and launch, not in the spring anymore, but we launch in the fall.
Let's see.
Yes,
I
sir.
promised I'd get you out here
Yep.
at 12:45.
Okay, one more question.
With all the sounding rockets and balloons and such, do you get involved with any drone technology?
We do, and we were showing you a picture of Global Hawks. We expect that the Air Force will come and use the Global Hawks for downrange, over-the-horizon communication. As we do these hypersonic launches, they need to be able to see further over the horizon, so that's one thing. But Goddard scientists are using drones, to conduct science, and we have a UAS runway, so we think the natural fit, and NASA Langley has a catalog of UAS that they have access to. So it's sort of like a rapid spacecraft office. We can go get our scientists from Goddard and get them to talk to the Langley folks. They can figure out what UAS they want to use, come to Wallops, do the integration just like we would on an airplane, and then fly from Wallops and then go global to do their science. So it's very much on our minds and how we can support our science. Great question. Love to take all your questions, but I have a meeting at 1 o'clock. Thank you for all that you've done for NASA Goddard, for our nation, and thanks for inspiring all of us younger folks that are trying to carry on your tradition. Happy Thanksgiving, everybody. Thanks for having us.